My name is Jim Schreckengast, also known as Schreck. I'm a strategist in the Hewlett-Packard Enterprise Open Program Office. One of the things I do at HPE is lead OpenAI technology compliance as part of corporate AI governance. And some of the things we wrestle with on a case-by-case basis include, is this open weight model really open? The industry struggles with this, by the way. They have put forth proposals that have very black and white definitions that exclude most of the models today. And we've seen a few proposals here to try to standardize on a definition, which we'll touch on a little later. But set that aside, there's some other questions too. Would teams have what they need, including permission, for the desired use case? Is the model safe to use? Is it biased? How is it trained? What guardrails are available? What does the team want to do with the technology? Does it meet our ethical standards? And what about usage restrictions? How do those impact the use case, and what kind of risks get generated as a result? You know, when I think about open weight models and the complexities of AI technologies, I'm reminded of the early days of open source, when the concepts of open and freedom were not that well defined and everyone was generating their own licenses. It seems similar to that today. However, this space is far more complex. For one thing, the software tooling, the models, the training data, and the weights may not all be provided. And if they are, they could be provided under different terms. And even if you have all that stuff, you're still dealing with a black box unless you have a lot of additional information about it. And the black boxes are often general purpose systems that can orchestrate behaviors, and that makes for a very novel, versatile, and powerful system. In many cases, they can do things that would have previously required explicit programming. Black boxes that may be unpredictable, but are certainly quite capable and quite powerful. And if there's one thing that Spider-Man taught us, it's this: with great power comes great responsibility. So, now, responsible machine learning and responsible AI have been concerns for a long time. But when the capabilities of generative AI models became apparent, it became clear that the difficulty of accomplishing this goal and the urgency increased quite a bit. So the natural question is, how can we ensure that generative AI and the systems that utilize the technology are built responsibly? Enter the Generative AI Commons. Now, this is a community-driven open membership initiative within the LFAI and Data Foundation. Their mission is promoting responsible, trustworthy AI, fostering collaboration, advancing AI literacy, and advocating for our community. And that community is thriving. We currently have more than 80 organizations and more than 200 active members in this area. Now, there are 3 working groups in the Generative AI Commons. The one I want to focus on today is the Responsible AI Working Group. The purpose of this group is to guide the ethical, fair, and beneficial development of AI systems. Members of this group created the Responsible Generative AI Framework, including these 4 principal authors and key supporting contributors. In fact, there were a huge number of contributors with very diverse set of backgrounds who developed this framework. They have a lengthy white paper that discusses the framework in detail. I think it's about 47 pages. It's a great read, and I encourage you to check it out. Of course, I can't cover everything in that paper in 30 minutes, so instead I'm going to give you a quick tour of 2 things from the framework: the dimensions and the responsible AI pathways. Now, the dimensions are a high-level set of principles that an organization should consider. It's the map that shows what a responsible AI system should look like. The responsible AI pathways are envisioned as a practical, actionable implementation guide for the map. This is a work in progress. It's intended to become a turn-by-turn set of directions that'll help developers, project managers, and organizations navigate the complexity of building and deploying responsible AI in the real world. They're intended to bridge the gap between the abstract principles and the concrete engineering and governance practices. Let's begin with the dimensions. What principles should a responsible AI follow? There are 9 dimensions to the RGAF. I won't read each of the 9 dimensions on the slide. Instead, I'd like to dive a bit deeper into each one. The first dimension is human-centered and aligned. Now, I want you to imagine an insurance company that deploys an AI-powered personal wellness agent to its members. Its goal is to maximize user engagement to encourage healthier habits. But instead of gentle encouragement, it accomplishes engagement by creating a state of perpetual health anxiety, emphasizing alarming medical news and flagging minor symptoms you might be having as a sign of potentially serious illness. It's aligned with the engagement goal, but it's misaligned with the human value it was supposed to serve. AI systems should be designed to improve human lives, respect human values, and avoid causing harm. Now, some of the challenges in achieving this include limiting the negative influence of human cognitive biases, improving lives without causing harm, keeping humans in control, and ensuring that these AI systems respect different cultural values and different perspectives. Ways we might meet some of those challenges include engaging inclusive groups, creating straightforward measures to track if the system is actually helping, feedback systems to maintain alignment, which is very important because things can drift over time, and establishing really good standards and guidelines for how we should be working with AI systems. Moving on to the second dimension, it's about being accessible and inclusive. Now, inclusivity is very important. Imagine a promising startup focused on traditional ethnic cuisine, and they go to a bank and apply for a business loan. The bank denies the loan, not because of its business plan or the merits of what it's trying to do, but because the AI that reviews the application is not inclusive of its cultural context, effectively creating an automated and opaque barrier to economic opportunity for entire communities. AI systems should be able to consider the needs of all segments of society, regardless of ability, background, or culture. Now, making sure that everybody has access and that the ability to interact with these systems is critical for equity. So this raises a number of key challenges. Bridging the digital divide, for example, making AI affordable, ensuring that AI systems work well for people with different abilities and backgrounds, and dealing with differences in technical infrastructure. Some ways to address this might include targeted funding and grants, investments in digital infrastructure, building partnerships to share resources and knowledge globally, and building systems to accommodate different languages and cultures. Now, when I give you these selected challenges and potential remediations, these are just examples. The paper, the white paper itself, goes into much more detail and has a much more comprehensive set of considerations here. So it really is a great read. The third dimension is about creating AI systems that are robust, reliable, and safe. Now, what if a company that manages its supply chain with an agentic AI, and due to a human error or software bug, 2 digits of the GPS coordinates of a shipping port are transposed? Now, this is something you wouldn't ordinarily anticipate in the design of a system. But you can probably bet that a human would recognize that pretty quickly. Instead, this system interprets it as the port having moved inland and reroutes a bunch of vehicles and shipments with disastrous results. AI systems should behave dependably and safely, especially in unpredictable or challenging situations. Now, what are some of the challenges here? Making AI systems robust and reliable in a variety of real-world situations, specifying behavioral boundaries, and closing loopholes, overcoming technical limitations that impact reliability, and verifying complex AI systems thoroughly and at scale, and that takes a lot of compute. Some vectors of attack include using AI-assisted protocols to ensure reliability and provide graceful fallback and proactive escalations, implementing guardrails to prevent dangerous, harmful, or even illegal outputs, feedback loops from continuous monitoring to improve the systems, and benchmarks to assess safety. The fourth dimension concerns being transparent and explainable. Now, what if an AI system was screening candidates for a highly competitive job, assigning a suitability score based on video interviews and maybe a resume? The candidate is rejected, but the company can't explain why. Did the system perceive a lack of confidence? Did it penalize the candidate for a gap in employment, maybe when the employee was caring for a sick relative? Was there a hidden bias against the candidate's gender, or maybe the university they attended? Users should be able to understand how an AI system makes decisions. This is a big challenge, especially with these large AI systems that are mysterious black boxes. We face challenges with making the systems trustworthy and easy to understand, balancing amazing capabilities with the need to explain how they work, providing that transparency while protecting trade secrets, and of course, open collaboration, open source, detailed documentations, and simple licensing. Those things go a long way toward improving transparency. But there's some other things we can do too. We could use visualization to illustrate how decisions are being made. We could extract explanations from complex models. We could standardize on regulatory frameworks that mandate transparency. Tackling this dimension effectively can make our black boxes a little more gray. In the fifth dimension, we want to address accountable and rectifiable AI systems. Now, how about a show of hands? How many people have experienced a large language model hallucinating, producing something that wasn't true in response to a prompt? Oh yeah, almost everybody. Now, what if an automated news article authoring system used multiple models and hallucinates a story accusing a small town mayor of embezzlement? It goes viral, the story goes viral, results in irreparable harm to the mayor. Who can the mayor hold accountable for this? And how can those damages be remedied? Is the news organization liable? The model developers? The organization that trained the model? Provider of the data? And perhaps more importantly, how does the harm get remedied? There needs to be clear mechanisms to assign responsibility for AI actions and to correct the harms when they occur. Now, this is a tough one. Some of the challenges here include tracing decision-making and potential biases, establishing clear organizational accountability up front for AI outcomes and decision-making, standardizing metrics and assessment frameworks, and compliance with and enforcement of rapidly evolving legal and regulatory requirements. Now, addressing these challenges, that's going to require clear policies and procedures for addressing errors or harm, fostering a culture of AI responsibility, and that goes through the entire AI life cycle. Supporting oversight and escalation through systems and user feedback, and having comprehensive documentation, audit trails, and monitoring systems. The sixth dimension is about making AI systems private and secure. Now, we've seen these kinds of stories all the time, but imagine an attacker guesses that an AI therapist might have been trained on private data and crafts a creative prompt that results in the system leaking personally identifiable information. AI systems need to protect user data from breaches and ensure that privacy is maintained. Challenges include figuring out how to use data to improve the AI while protecting sensitive information and user privacy, complying with data protection regulations, preventing unauthorized access, and guarding against attempts to trick or manipulate the AI system. Now, fortunately, there are a lot of well-established security practices to help overcome these challenges, including advanced encryption, access controls, anonymization, privacy by design principles, robust security approaches, including regular audits, monitoring, and the use of sandboxed environments. Some emerging techniques are coming out for personalizing AI systems while protecting privacy and foundation models as well. The seventh dimension is about making AI systems compliant and controllable. Now, can you imagine a marketing AI agent that's tasked with creating the most effective marketing campaign? And the system does this by scraping personal data from social media accounts in violation of the GDPR. They create fake accounts to give glowing reviews in violation of FTC regulations. And they generate deep fake videos of your favorite celebrities endorsing the product in violation of their publicity rights. AI systems need to adhere to the laws and regulations, and humans must be able to direct or shut them down when necessary. A bunch of key challenges here, including staying on top of rapidly evolving laws and regulations, making sure humans can control and override AI systems when needed, monitoring AI systems in a performant manner, and adapting automated compliance monitoring to track current rules. Approaches for this include, first and foremost, staying informed, which is difficult enough as quickly as things are changing in this environment. Prioritizing privacy standards, implementing a comprehensive control mechanism and guardrails, and establishing systemic risk assessments and audit protocols. The eighth dimension concerns making AI systems ethical and fair, unbiased. Now, you can conceive of a smart city that uses a generative AI to create a new urban development plan to optimize public resources and improve quality of life. The system is quite impressive. It's been trained on decades of historical data, which unfortunately includes patterns of segregation and discriminatory housing policies. When asked to identify areas for beautification and new investment, the AI system prioritizes historically white, affluent neighborhoods. AI systems should not create or perpetuate unfair biases and should treat all individuals and groups equitably and consistently with moral principles. The challenges, of course, include making sure AI benefits are distributed fairly across society, balancing ethical considerations with practical implementations, maintaining alignment, just as we had to do in the first one, and establishing and adopting well-accepted measures of ethical AI operation and fairness. To meet these challenges, we need to include diverse perspectives in our design, development, and deployment. We need to establish guidelines and embed ethical considerations at all times, curate diverse training sets, and audit and reevaluate AI systems for fairness across diverse groups. The ninth dimension is about making AI systems environmentally sustainable. Now, you may have seen a recent analysis by the Washington Post that showed that GPT-4, when producing a 100-word email message in response to a prompt, consumed a little bit over a 16-ounce bottle of water to cool the systems. Multiply that by the estimated billion queries a day, and it's clear we have an environmental sustainability problem. Even improvements in model efficiency can backfire. If a more energy efficient generative video model is so compelling and becomes so inexpensive as a result of it being more efficient, that it drives demand for energy usage to unimaginable and unsustainable levels as hours and hours of video are created recreationally, that's unsustainable. This is called the rebound effect. The development, deployment, and operation of AI should minimize negative impacts on the environment. Some of the challenges here include limiting the negative environmental impacts of data centers and computing infrastructure, reducing the high energy consumption and carbon emissions, measuring AI's total environmental impact, and addressing the rebound effect I mentioned earlier. And some approaches to meeting those challenges include creating and deploying sustainable scoring criteria, publishing best practices and environmental impact metrics, building more energy efficient hardware and AI methods, using renewable energy for AI operations, designing hardware for durability and modularity, and collaborating with the Green Software Foundation and other groups like that. So those are the principles, the dimensions of the RGAF. Responsible AI systems really should adhere to these principles. And those principles align quite well with regulatory schemes and other frameworks. And they benefit from the philosophy of open collaboration, which is one of the reasons I see open collaboration becoming the dominant driver of innovation in the era of responsible AI. Now, frameworks like the one that was shown just before this session, the Model Openness Framework, defines degrees of completeness and openness instead of a black and white definition. That should enhance our ability to craft effective strategies for responsible AI development. Security efforts in SALSA, SPDX, and the OpenSSF are all relevant to these principles. The Decoding Trust Framework and the benchmark built upon it should help us evaluate the trustworthiness of AI systems along with each of these dimensions. And there are other helpful benchmarks, such as the ML Commons benchmarks. And the Green Software Foundation's work is very relevant to our 9th dimension. And I'm sure there are others. For example, I know the team is working with the Trusty AI project right now. Are there other projects that you know about, that you're aware of, that support these dimensions or principles, things that aren't on our radar right now? Anything involving measurement, evaluation, or remediation? Anyone? Yeah?
There's a Responsible AI special interest group that is being formed with FINOS, FINOS organization. They are also working with AI readiness, so it works with private and security and threats of LLM.
Okay. So that's, say it again, which group is it?
FINOS.
FINOS?
Finance and open source.
Finance and open source, okay.
They're having a conference right now in London on Open Source Finance Forum. Yeah.
Okay.
I'll connect with you.
Great, thank you. I appreciate that. I saw another one. Ria.
The United Nations has the Sustainable Development Goals that would intersect really well with environmental sustainable and maybe also with some of the accessible and inclusivity goals.
Okay. Okay, in the United Nations.
Yes.
It's a group.
They actually just had their open source week last week.
Okay.
Focused on all of the open source intersecting with SDGs, and I think there could be a really strong play there for AI as well.
Okay, great. Any others? Okay. Now, throughout this talk, you may have noticed that I've talked about AI systems. I want to emphasize that the RGAF applies to much more than any AI model. Even simple RAG systems have additional components that we have to think about these principles, such as a vector database. Agentic AI systems are on the rise, and they include function calling and tools, and possibly multiple agents in different roles collaborating on different tasks. We really need to ensure that a comprehensive assessment of trustworthiness is performed on entire AI systems when we consider these 9 dimensions. So how do we operationalize the RGAF? How will we get there? We need an action plan. The Responsible AI Pathways Initiative will create the blueprint or the map for translating these dimensions or principles to concrete actions. It's going to be built on the RGAF, which is essentially the North Star for this effort. And in essence, the action plan will consist of 4 pillars. First, in the Help Humanity pillar, we're asking the big long-term questions. How do we ensure AI benefits humanity as it becomes more powerful? This is our strategic, forward-looking work. Next, in the Align LF with the world of AI, we're mapping the entire AI landscape, both our projects and the work of others. The goal is to identify gaps, avoid reinventing the wheel, and find the best opportunities for collaboration. Then, in order to evangelize the dimensions, we're diving deep into each of the 9 dimensions like security, safety, sustainability, all of them. We'll be publishing white papers and practical guidance to give developers the specific knowledge that they need. And then finally, we want to make the RGAF practical. So we're grounding everything in the real world. This means focusing on use cases in industries like healthcare and finance, and providing open source tools, best practices, and training to make responsible AI ready for everyone. The RGAF, it's more than a collection of principles and guidelines. It's really a commitment to ensure that AI systems serve humanity in a way that's fair, inclusive, and beneficial to all. And it's a collective responsibility for everybody. This isn't just about technologies and technologists. We all have a role in advocating for these principles and to engage in the advancement of AI technologies that reflect our collective values and aspirations. This is a massive but critical effort, and it needs a community. If you're working on a project that relates to responsible generative AI, we hope you'll join this effort. And if any of this resonates with you, I hope you'll consider being part of the effort to shape the future of intelligent and conscientious machines, and join the effort. There's some links here to help you get started. I hope to see you there. Thank you.